Okay, of all the transformations that we do, rotations are probably the hardest to get the hang of, and maybe it'll come really naturally to you. But I'm just going to go through this example. I'm going to do all three problems kind of quickly, but just pay attention to the commentary, I guess. Maybe take some notes would be a good idea, and just kind of pay attention to what we're doing. 180, first of all, unless it says clockwise, like it does in number 7 where it says clockwise, unless it says clockwise, the way of rotation is going to be like this, and that's called counterclockwise. So we're going to rotate in this direction. If you remember, at some point we talked about quadrants 1, 2, 3, and 4 in that direction. So we go from 1 to 2 to 3 to 4. And so most of our rotations, unless they say otherwise, are going to be in that direction. If they say clockwise, what they mean by clockwise is, what they mean by clockwise is it moves the same direction as a clock, not one of the digital clocks that tells you the numbers, but an analog clock, like what's in our classroom. Moves from 12 to 1, 1 to 2, that direction. So clockwise is that direction. Counterclockwise, the normal way of rotation is not written, is this direction. Okay, so we're going to rotate ABCD 180 degrees to the left. And then part of the reason this is going to be somewhat difficult is we didn't really get a chance to go over angles last year like we were supposed to. But 180 degrees is half of a circle, halfway around. So if you picture, we're going to rotate each of these points halfway around, 180 degrees. Another way to look at it is 180 degrees takes your coordinates and flips both of them. So it's if you're positive, you're going to be negative. Okay. So let's go ahead and do this one. A is at 0, 0, and we're using 0, 0, or we're using A as our point of rotation or our center of rotation. And so that's what we're rotating around, is the center, or the origin in this case. And so A is actually not going to move. It's at 0, 0. So now we're going to move it to negative 0, which is just 0, 0. So A stays where it is. So that's also A prime. B is currently at 1, 2, positive 1, positive 2. So we're going to move it to negative 1, negative 2. So our new B point is right here. There's B prime. C is at 4, 2. So we're going to go to negative 4, negative 2. And D is at 0, 3. So 0, negative 3. Okay, again, we can't, 0 negative is still just 0. So there's our C prime, and there's our D prime. Let's see if I can draw this, if it'll straighten things out for me. And not great. Let's try again. Maybe if I stay better on the line. Yeah, close enough, I guess. It should that green line should right here should be on the axis, not above it, but that's okay. So our rotation of 180 degrees would look about like that. Each degree of rotation is going to be different. So if we did a 90 degree rotation, right, we would, so current B went 180 degrees all the way down to its opposite. 90 degrees would be halfway there. We can worry about that more later, I guess. Might actually help to use a protractor for this. I'll have to see if I can use that. Anyway, let's go ahead and do a 270 degree clockwise rotation. And I don't know if this is what was intended, but I'm going to actually start with our new image, our A prime, B prime, C prime, D prime, and I'm going to go 270 degrees clockwise. So 270 degrees clockwise Actually, I'm going to make this into a second video. So first video, we're going to call that good, and then I'm going to come up with a follow-up video.